Okay, so a quick revision for the students who were not joined in the last class. Okay, so the difference between, so lastly we talked about chemical and physical properties. Now here is another category of the properties: intensive and extensive properties. Okay, intensive properties do not depend on the amount of matter in a sample. Okay, for example, if you just take 1 glass of water and you just boil it, it will boil at 100 celsius, 100, isn't it 100 celsius, correct? Thumbs up. Excellent job. Yes, lots of thumbs up. Now if you take 2 glasses of water, it means it will also boil at 100 celsius, or will it take 200 celsius to boil? No, excellent. Your 100 Celsius. So this means the properties which do not depend on amount of sample present inside it. Those type of properties are called as intensive properties. Now, on the other hand, extensive or opposite of intensives, where amount of sample matters. Okay, amount, how much matter is present inside a sample, that things matter. Okay, for example, weight. Okay, if you have more fat quantity, this means their amount of matter have increased, the weight gonna increase. So this is the thing. Okay, so is it clear to all of you? Especially the people, especially Jerry, Zoo, which were not here in last class. Excellent job. Okay, now let's move on. One of the important differences, well, basically the chemistry all depends on atoms, elements, and you know that all of you will have to discuss these things. Okay, and I remember that in my last class when I asked you that what was chemistry, everyone was like, yes, it is study of atoms, molecules, chemicals, and this type of stuff. Yes, so today is the day that we will spot the differences between them. What is an atom? Basic building block, everyone can say, just copy paste it. Okay, so atom is just a basic building block of everything. Okay, everything which exists in this universe. Okay, somehow atom is involved there. Okay, so it's a basic building block. And what does this mean? The word atom basically means indivisible. Okay, we cannot divide an atom. Okay, we cannot break an atom. Okay, so this is the case. So this is atom. Is it clear? Now here, fancy table, huh? Scary one. Okay, I could see it. Yes, it is scary. It is. Okay, well, it's not scary. This is, okay, this table shows that how many atoms we have in this world. Okay, for example, we have lithium atom, we have sodium atom, we have potassium atom. So each atom have its particular name, and we have arranged all the atoms in a very beautiful table. Okay, this one and this table have a very fancy name named as periodic table. Its history and its details we're going to study in the next chapter, but for now just remember that there are different names to different atoms. Okay, such as all humans have different name. My name is Binte, my student name is Zoo, the other one is Jerry. Okay, but we all are humans, so these all are atoms, but still they have different names. Okay, excellent. Now atoms and molecules. Okay, so what is molecule? Molecule is a combination of atom. Okay, molecule is combination of atom, remember. Then what is a compound? Excellent question. Compound is also a combination of atoms. But what's the difference between molecule and compound? Okay, molecule is a combination of same atoms. Okay, well, compound is a combination of different atoms. Okay, can you see over here? Please see over here so that I could make the concept easier for you. Okay, so the first term which we learned was atom. Okay, atom is the basic building block. There could be different atoms such as hydrogen, such as helium. These are the names, different names for different atoms. Okay, now if the other word is element. Okay, let me talk about element. What is element? Element and atom are just same things. Then what's the difference? In atom, if I say hydrogen atom, this means I'm just talking about one atom of hydrogen. Okay, if hydrogen atoms are here and they are chilling around, okay, they are not bonded. Okay, they are not bonded. They are just sitting, chilling, chit-chatting like that. Okay, but they are not physically or chemically bonded. Then I will say this is a hydrogen element. Okay, this is a hydrogen element if they are just sitting together like that. Okay. Then what's molecule and what's compound? What's molecule? Okay, molecule. Okay, and what's the compound? Over here. Now, in molecule, what happened? That molecule is a combination of, okay, it's a combination of same atoms. Now, let's suppose if hydrogen and hydrogen, okay, they just bond, okay, if they just make a bond, okay, chemically bonded, okay, then this will create a hydrogen molecule like this, okay. But if hydrogen, okay, it get a combination, it combined with oxygen atom, which is two different atoms, then they will create a compound, okay. So molecule, okay, it's a combination, okay. Let me just write it with different color. Okay, it's a combination, of same atoms, okay, coming together, bonding, okay. And here compound is a combination of different atoms, okay, combination of different atoms. Okay, I'm making it simple. Why? There is a reason to it, okay, combination of different atoms. The reason is that maybe you have heard a lot of fancy definitions to it, but the reason is that when I was at my high school, I never got the difference between them. So I just want to make it simple so that my students do not get confused in that, okay? Excellent. So over here, so atom, element, molecule, and compound. These terms are clear. Please show me thumbs up if it do so. Here, just a quick review. Okay, so atom, when we are just talking about one atom individually. Okay, this is a molecule. It's a molecule. Okay, it's a molecule when similar atoms come together. Okay, and this is a compound when different atoms come together. This is a compound when different atoms come together. Okay, so this was the case. But today, the chapter which we're gonna start, it is about mixtures and compounds. Okay, so in compounds, I already told you that compound is a combination of different atoms coming together and bounded. Okay, they are making an interaction with one another. Okay. Yes, chemical. Yes. That's true. Okay, now today, this chapter, as I told you, is one of the easiest chapter in chemistry books. And the topic which we're going to start, it is the difference between compound and mixture. Okay, so over here, compound when two or more elements, don't get confused with elements and atom. They are same thing. So elements mean like exactly the atoms chilling together. Okay, so but the same atoms. Excellent job. So two or more elements, or you could just use the word atoms if it suits you. So two or more atoms combine together chemically. So here hydrogen and oxygen, two different atoms. If they combine together chemically, they will make a totally different substance, which is water, H2O. In mixture, remember, two or more substances combine together physically. Remember, physically. So their chemical identity will not change. Chemically means that their chemical identity will change, okay? So together physically, so such as table salt, which is sodium chloride, and water. Both of them, they come together, okay? It's called a mixture, okay? The mixtures which you see in regular life, it's coins, okay? So it's a combination of copper and tin. Okay, so mixture when two or more substances combine together physically. Compound when two or more atoms combine together chemically, okay? Any confusions? No. Okay, let's move on. So here, the other differences, okay? So here, particles lose their original properties in compound. Okay, let's suppose hydrogen and oxygen, okay? When they were not combined, okay, when they are individual atoms, okay, they act as a gas. But once hydrogen and oxygen, they combine together, okay, they will create water, okay, they will create a compound H2O, and now they have changed their state to water, which is liquid. Do you agree? So what happened that in a compound, okay, when a chemical combination happens, particles lose their original identities, okay, their original identities where they exist as gases, isn't it? But over here, particles retain their original properties. In mixtures, particles retain their original properties, such as if you make a mixture of pebble and water, pebbles will be pebbles, water will be water. After the mixture, after they combine, they will still be that. Okay, so this is the second difference. Okay, the third one, important one. Okay, let me erase it. Okay. Yes, I was taking class. Okay, so homogeneous mixture. Whenever this word homo means same. Remember, this word means same. Homogeneous composition means that you cannot spot particles, okay? So if it's a water, you cannot spot where is hydrogen, where is oxygen. Can you in a water? No, we cannot see where is hydrogen and where is oxygen through our eyes, isn't it? Yeah, so we cannot. So this type of mixture where we cannot spot the things, okay, by our eyes, this is called as homogeneous mixture. Does it make sense? But over here, okay, in mixtures could be homogeneous or they could be heterogeneous. Okay, homogeneous. One of the example is when you mix salt and water. You cannot spot the particles of water and salt once it's mixed. Okay, but heterogeneous, such as over here, pebbles and water, it's still a mixture. Okay, they are not chemically combined, but we cannot see. We can easily identify pebbles and water. Okay, so this is called other examples of heterogeneous mixture. Okay, of the heterogeneous one is this one. Okay, the word hetero, as you know, it means different. Okay, one of the best examples which you can go and see in your homes, it is oil and water. Mix oil and water, and you can easily see that oil and water easily spot the particles. Okay, so in mixtures, the composition could be homogeneous or it could be heterogeneous. Okay, so it could be both. So this is the case. The other example is pizza. Okay, pizza is a mixture. It's a mixture of mushrooms, cheese, everything. You can spot it easily. Okay, so this was the third one. Okay, so the first one we studied that in compounds they are chemically bonded, in mixtures they are physically bonded. Then in compounds we saw that the particles lose their identity. In mixture, particles retain their identity. In compounds we form homogeneous mixtures. In mixtures homogeneous composition. Sorry, and in mixtures we found make homogeneous or heterogeneous compositions. The next one, okay, components cannot be separated by physical method, okay, or by easy method. This doesn't mean that we cannot separate them. We can separate them, but they cannot be done by physical methods or the easy way. Okay, so you cannot just separate hydrogen and oxygen by the regular filtration process, which you do, or can you? Excellent, excellent. Yes, we cannot. Excellent. Okay, so compounds can be separated by physical method. Okay, in mixtures. Okay, in mixtures, this is a mixture and this is a compound one. Okay, we can easily separate pebbles and water by filtration, which or you can just take a stainer to do that, isn't it? This one, pebbles and water, easily done by that, isn't it? Excellent job. Okay, now let's move on. Okay, this is an important one. Okay, so any questions so far first? No? I could see an O and O from everyone. Excellent job. Okay, so every compound has its own chemical formula. Okay, in compounds, remember that whichever compound you will produce, it will have its unique identity H2O, unique formula. But in mixtures, no chemical formula. Okay, sugar solution, if you just mix sugar and water, they will make a sugar solution, okay, mixture, but they don't have a chemical formula where I could say, okay, sugar solution is C6H, something like this. No, we don't have that, okay? So this is the other case. What does that mean? Compound has fixed composition by mass. Let's go on this one. Well, this means, okay, all of you know, remember, fixed composition by mass. Okay, so Jerry, you know, please go ahead. Well, it's a good guess. Okay, but let's elaborate on that. Compound has fixed composition by mass. This means that whenever, in any conditions, if I mix 2 hydrogen atoms with 1 oxygen atom, I will always create water. Okay, but what if I just do a small change? Okay, so I thought, okay, I just saw, okay, I'm taking 2 hydrogens, why not I take 2 oxygens as well, so I could create more water. Okay, let's see. So H2, I just changed one thing, I just added 1 oxygen. Now do you think a water will be created? Yes or no? Yes, but see, the answer is no. Once you add another oxygen, totally different compound will produce, names as hydrogen peroxide. H2O2. So what did I do? I didn't do anything. I just added 1 oxygen, isn't it? And the thing's gonna change. What does that mean? Compound has fixed composition by mass. Okay, they have a very precise fixed recipe, you could say. Okay, if you just change one ingredient, just a little one, you will get a whole different thing. But over here, what happened? Mixtures have no fixed composition. Just imagine if you just put 1 tablespoon of sugar in it, is it a sugar solution? Yes or no? Okay, what if I put 2 tablespoons of sugar? Is it a sugar solution? Yes. What if I put 3? So increase doesn't matter. The thing gonna remain same. Okay, so for now we just completed. Okay, the first part, that what's the difference between compound and mixture. Okay, let's go one by one. Yes, Sue. What is a compound and what's a mixture? Excellent job. Okay, so compound, when two atoms or two substances or two elements, they come together, but they're combined chemically. Okay, mixture, when they are combined physically. Excellent. Second difference. Yes, please, Jerry. Excellent job. Compounds have fixed chemical, compounds particle lose their original properties, and the other one is particles retain their properties in mixtures. Excellent. The next one is that in compounds, homogeneous mixture, in mixtures, hetero and homo both. Okay, compounds cannot be separated by physical method. Mixtures can be separated by physical method. Every compound has its own chemical formula. Mixture has no chemical formula. Compound has fixed composition by mass, and mixtures have no fixed combination of mass. But the thing is, you will ask that, Miss Bintha, you have been talking a lot about mixture. What is a mixture? Here we go. When two or more substances, remember, substances are combined together physically, in any ratio. In any ratio means the same thing. If I add 1 tablespoon of sugar, it's still a sugar solution. If I add 2, it's still a sugar solution, okay? So one of the examples, okay, is sugar solution. Okay, second one is carbonated drinks or fizzy drinks. It's a combination of carbon dioxide and water combined together physically. Coffee, water and coffee. Air is an example of mixture, because in air, nitrogen, carbon dioxide, oxygen, all of them are just physically combined. They are not chemically combined, okay? So it's a mixture. But the question is that if I say, my lovely class, here are 3 glasses of water, okay, and I just put 1 tablespoon of salt here, 1 tablespoon of sugar here, and you could say a tablespoon of pebbles here, okay? Please answer me. In salt and sugar and pebbles, in which of these I will get a homogeneous solution? Homogeneous mixture. In which one? Excellent, first 2. So in this one, homo, correct? And this one, homo. But this one, it's a mixture, do you agree? Yes, it is. Excellent. But is it homo or hetero? Hetero, good job. So then what is a solution? Here we go. Remember, in homogeneous mixture, or you could just say uniform composition, it's another word, don't get confused, okay? Both of them mean same. We cannot see the particles, we cannot see particles, but we can see particles here, so it is a heterogeneous mixture. So what is a solution, and how solution is different from mixture? Here is the case. A homogeneous mixture. Remember, which mixture? Not all the mixtures are solutions. Remember, not all the mixtures are solution. Only a homogeneous mixture of 2 or more substances is called a solution, okay? When a mixture is homogeneous, then that mixture is called a solution. So over here, if you see, do you agree that salt and water is a solution? Yes. Sugar and water is the solution? Yes. But pebbles and water, is it a solution? No, it's not a solution, but it's a mixture. Is this thing clear? Okay, so there is a difference. Not all the mixtures are solutions, okay? But a solution is a mixture. This is the case, okay? So a homogeneous mixture of 2 substances. Is this thing clear? Okay, now have you heard about the word solute and solvent? Solute and solvent. Okay, so all of you by now, okay, so far you understand what is solution, what is mixture, what is compound, atoms, and element. Is it clear? Thumbs up. Please show me thumbs up if these things are clear. Excellent. Okay, so solute and solvent. Let's suppose I say you over here, Jerry, please make me a lemonade, okay? And he just poured some water, correct? And then he took sugar, which is an important ingredient, okay? So let's suppose if this is 1 glass of water, okay? And 1 tablespoon of sugar, okay? Spoon. Which one is more? sugar or water? Excellent. You will be like, Miss Bintha, come on. Easiest question. Water is more. Okay. And do you think when I mix them, it will create solution? Excellent. Remember, here is the case. In solutions, in solution, we always have two quantities, okay? Not quantities, we have two things, okay? One is solute and the other one is solvent. What's the difference? So solvent is the one which is present in a big amount, which is present more, and solute is the one which is present less, okay? Now to make things more clear, here they are. In a salt solution, okay, in a salt solution, salt is smaller. Okay, let me just change the color. Okay, salt, okay, is smaller. Correct? In sugar solution, sugar is smaller, isn't it? It's less. Okay, then this is called a solute. Solute, the component of a solution which is present in smaller amount. That's it. Water in both of the solutions, it's present in a large amount, okay, it's more. The solvent, the components of solution which is present in a larger amount, okay. Now to avoid confusions in exam, can you see solute spellings? They are less. So less, solute. Solvent, they have a little big spelling, okay. Exactly, big spell, okay. So this is called as big one, okay, just to give you a quick reminder, okay. So I know you have learned these things in your years 8 and year 7, so I told you this is the easiest chapter in the history of mankind, okay. But here the things gonna go a little different. Let's see. Okay, so let's suppose that I just ask Jerry, okay, as I was saying to him, that kindly make a lemonade. So he asked me, Miss Binte, how many tablespoons of sugar should I have to add? So I said, okay, just add 1 tablespoon. Do you agree that when he will add 1 tablespoon, which is solute, to a solvent, which is water, it will dissolve easily? Nothing will be left beneath. Do you agree? Nothing will be settled down? Excellent. Nothing will be seen here, correct? So and then I said, okay, add 1 more spoon and it will be dissolved easily, isn't it? Okay, whenever a solution is in a position, okay, where you add a solute, okay, and it get dissolved fully, that type of solution is called as unsaturated solution, okay. Unsaturated solution means that solution, okay, have capacity, okay. Unsaturated solution mean, okay, let's make it easy, solvent have capacity to dissolve solute, okay, dissolve solute. So this is the first condition of when you mix something in a solvent, okay. So if a solvent is dissolving, nothing is left behind, nothing is settled down, this means the solvent have a capacity to dissolve a solute, okay, and we call it unsaturated. Does it make sense? Excellent. But let's suppose if I say him to put 32 or let's suppose 24 tablespoons of sugar, what he gonna do? What eggs? Not table, okay, thank you, it's table, okay, table. Okay, 24 tablespoons. What will happen? Excellent. Some of the sugar, you will see that it will settle down here and some will get dissolved. When a solution, when you see this condition of solution, okay, then we call it that solution is in its saturated position, saturated solution. Then we call solution a saturated solution, okay? Or in easier words, you could say that solvent do not have capacity to dissolve solute. You could say this one in easy words, okay? Yes. Okay, so when you see that some of the sugar is settled down and not all of it is dissolved, then this is called a saturated solution. Is it cool? So the first one was unsaturated. Unsaturated means it have capacity. Okay. The second one is called saturated. Okay. Saturated means it do not have capacity to dissolve. Does it make sense? Excellent. Should I move on? Let's suppose what Miss Binte do that she will take that unsaturated. Okay, so first of all, okay, unsaturated solution, unsaturated solution, a solution which can dissolve further amount of solute, which have capacity to dissolve a solute at a particular temperature that is called as unsaturated. Saturated solution, opposite to it, a solution which cannot dissolve further amount of solute at a particular temperature. At a particular temperature, remember. So we're gonna keep the temperature same, such as 30 Celsius, okay? At a particular temperature, this is called a saturated solution. But there is one other solution too. Let's suppose what? Let's suppose that Miss Binthe just took this saturated solution. The sugar was here, as you could see in white color. It was settled down. She took saturated solution and she just put it on a Bunsen burner, okay? Yes, just increase the temperature. So once the temperature increased from 30 Celsius to 60 Celsius, let's suppose, you will see a magic. You will see that the sugar which was settled down, it gonna dissolve in the water. It will dissolve in a solvent. When I increase the temperature, okay, of a saturated solution, and sugar get dissolved. Now the name of the solution will be supersaturated. Supersaturated means that this solution have dissolved more than its capacity. Okay, so and how does that happen? That is effect of temperature. Okay, more than dissolving. Supersaturated solution mean dissolving more than capacity. Okay, all of you are here. Excellent. Okay, so supersaturated solution means that it's a solution which has dissolved more amount of solute than can be dissolved, more than its capacity. Okay, so this means a supersaturated solution is a solution which has dissolved more than its capacity. Okay, dissolved more than its capacity. Okay, so first I just took a saturated solution. Okay, so this was a saturated solution means that Exactly. Saturated solution means that some of the sugar was settled down. Okay, it do not have capacity to dissolve it. But once I increase the temperature of saturated solution, I just provided some heat to it, you will see that this sugar will dissolve automatically. Okay, so this means that now this heated one, okay, this heated one is super saturated. Why? Super. Okay, so this means more than its capacity. Does it make sense? Yes, please. Excellent question, Maria. Excellent. How does that happen? See here, at 30 Celsius, do you remember in our previous classes we were talking about solid, liquid, and the particles inside them? At 30 Celsius, let's suppose the liquid particles were at this position. But do you agree that when I increase the temperature, they will gain more energy and they will move apart? They will move further away from each other? Excellent. Once they move further, now they can accommodate sugars between them. Okay, so this is the reason. Okay, super saturated. Excellent. Okay, so in today's topic we just talk about compound. There are difference between mixtures and solutions, and different types of solutions such as unsaturated, saturated, and supersaturated. Now these terminologies are important for our next class when we're going to study that how to separate these solutions or mixtures. Okay, any questions so far? Please. Excellent job. Yes, let me repeat one more time for all the students. Yes, so unsaturated means a solution which has capacity to dissolve. Saturated means that which do not have capacity. Now the things are just settling down, so it does not have it saying it just show red light. I cannot dissolve more. Saturated. Super saturated, if I heat saturated solution, it will automatically dissolve that one, the solution, the solvent which was settled down, and now it becomes super saturated. Okay? Excellent. So all of you are ready for the quiz? Okay, I could see the excitement. Let's start. Okay?